All right. Hi again, everyone. Glad that you're here. So, my name is Alexandre Chabot-Leclerc. I'm the director of the Training Solutions Group here at Enthought. Previously, I was the lead instructor, which means I spent about half of my time on the road teaching scientific Python to engineers, scientists, data scientists, and analysts. And I'll be the host of this webinar. So a few words about logistics. We'll be responding to questions live via the questions box of the GoToWebinar interface. And then all registered attendees will receive a link to the recording that we'll be sending soon after. So let me talk a little bit about the schedule for today. I will say a few words about digital transformation and how it fits with automation, or how automation fits within digital transformation. And then also a few words about Enthought, who we are, and our approach to automation, scientific computing, and digital transformation. And then the meat of the webinar will be about automation principles that I will illustrate using case studies that we've sort of distilled from experiences that our students have told us about and that we've had with our customers. And then I'll end with the discussions of the next steps that you can take on your automation journey. So Enthought's been around for a while, 17 years and counting. We have a focus on digital transformation for science companies, and we have a global presence. Our team is highly educated and has deep scientific expertise, with most people with advanced degrees on the technical team, and many of those, 70% or so, having PhDs. So when we talk about our focus on digital transformation, we know there's a lot of confusion out there about what it means. Some would say that it's an overused term, and we don't really disagree with that, but we still use it because we think it expresses a goal, a state, that many science-based companies have not reached, and that we think we can help them reach that state. So you can frame digital transformation around what people like Jeff Bezos, the CEO of Amazon, has said. So he mandated that all divisions, all business units at Amazon provide data and services through structured interfaces. That's how teams must communicate. There's no special case. All services have to be built like that from the beginning. So this kind of mandate, this is clearly why Amazon is one of the leading companies when it comes to maximizing the value of all the data that they collect and generate. And then you have people like at JP Morgan who say that they don't have regular, quote, business analysts anymore. All of their analysts need to know how to code. So those two things together and more, they're really signs that transformation is happening. So on the technical side, when we have customers who come see us with their problems, we really sort of notice four main themes. And the first one is data problems. Our customers come with data problems and they know they have data problems. And then they sometimes come because they have bottlenecks in their processes and they don't know that automation is the answer. That's where we can typically get quite impressive improvements, sometimes of the order of 1,000 times faster than the original process. And that's why we're focusing on automation in this webinar. There are huge, obvious gains that can be made here to reduce repetitive work and to be more efficient. And then we also see customers with modeling problems. For example, we're helping some customers now modeling the properties of a polymer they're developing. And we also use predictive tools, AI, machine learning, to help scientists identify new solutions to their problems. And how do we solve those technical problems? We take advantage of the deep scientific expertise of our people. They're people who have PhDs in math, in physics, in chemistry, in engineering, and in bioscience. We've picked these scientists because they've showed that they could use software to accelerate their own research and the research of other people around them. And we use the sum of those experiences to do the same kind of transformative work with our customers. And we've been doing that for 17 years. So this allows us to bring a unique view to our customer's problem. We're not just programmers, we're scientists who code. We can go straight to the heart of the scientific problems our customers have. And even though this work brings in a lot of value, there's a missing piece to get the most from these technical changes, and it's organizational change. So when we introduce a new technology at a customer, we realize that there are restorative forces in the organization that sort of keep the organization where it is. And we can improve the work of a team, but for the whole organization to reap all the benefits, there needs to be communication across business units. We've been doing that for a while, and we see this intersection of these three requirements to get the most business impact. You need science, you need code, software, innovation, and you need organizational change. These three things together, that's why digital transformation means to us for science companies. We know that change is not simple. It's a big process. I'm illustrating here some of the pieces involved. At this point, you might be wondering, why is he talking about all this digital transformation in a webinar about automation? That's because automation it's a technology project. It's just one tree in the forest of transforming the company. It can make your work and your team's work more valuable and efficient, but alone automation cannot transform the business. Automation is necessary, but it's not sufficient. So, in addition to the technology solutions that we provide, we also provide people capabilities that are needed to make the technology successful and sustainable. This is something we know well from training nearly 1,000 people per year and from doing immersion training with our customers. So during that training, our clients, scientists, they spend weeks or months with our developers. They sit side by side and they learn how to build software, how to build mathematical models. And as the business changes, you also need change management. The management layer in the company needs coaching. People need to know how to approach innovation. They need to learn, for example, that AI is not magic, that there are things it can do and things it cannot do. And you also need a governance team on top. You need someone who can define what digital transformation means for that company, someone who can decide what to do next and solve conflicting requirements in ways that are best for the business. So, for example, at one of our customer sites, there's an R&D group hosted in one of the factories. And one day, the IT team in that factory noticed some suspicious activity on the network, and they decided to just block the internet for everyone. Obviously, that had a terrible negative effect on the business and on the digital transformation happening. So this is a prime example of the need for governance, right? You need someone who sees the big picture and who can make changes to make sure everyone has everything they need to do their job and maximize business value. So in this case, it's network safety for the factory and it's internet access for the R&D team, but obviously it's not always that simple. And finally, I want to show you this slide here because it has a big impact with our customers. So the graph represents the business value a company can generate with a given organizational and operating model. So new technologies, automation, data consolidation, modeling, prediction, they can prop you up from level 1 to 2 to 3. They allow you to add incremental value to the business, but they don't change how the company fundamentally operates and thinks. The company is sort of stuck at a lower state of business value because because the organizational model and the operating model, they both enable a certain level of business value, but they also put a ceiling on the maximum value that can be produced within that configuration. So if you want to jump to the next level, you need the new technologies and you also need organizational changes that will enable you to really take full advantage of the possibilities that the new technologies can provide. So for example, a taxi company, they can add new technologies. They can ask their drivers to use Google Maps as much as they want, but they'll never become Uber and be worth billions of dollars without transforming the whole business, right? They need to significantly redesign the underlying organization and the operating model. If you're an academic, if you're at a school, you're probably wondering, like, how does all of this apply to me, to you? So think, for example, about the benefits of having a central repository of labeled data instead of having each researcher store their own, and how having automated analyses prevents errors, helps repeatability and reproducibility. So now think about how you would redesign your entire lab operations and what roles your researchers and your scientists would fill if you had these technological capabilities in place. And they could spend a lot less time doing grunt work and a lot more time thinking about research problems. So making use of all the available data instead of just the data they collected and so on. So now that I've given you the context about where automation fits in, I'm going to switch gears and focus on the details and how and why you want to do it, how it works, and what you can do. So you probably want to automate because you're tired of repetitive work, or you can't keep up with the amount of data you have to process, or you want to dramatically increase your team's efficiency. So what I want to give you is ideas about the tasks and workflows that lend themselves well to the power of automation, and how to think about those workflows and how to identify the steps to automate. I'll be illustrating these principles with case studies distilled from problems mentioned by hundreds of students I've taught and many of our customers. All right, so automate, but automate what? I think of automations in as sort of two classes of problems. Vertical automation, you have too much data in a single project, like too many audio files to label, too many images to categorize, too many machine output to process. And then horizontal automation. This is when a process has many steps that can be error prone, or a process that is repeated multiple times, like creating weekly reports or monitoring the daily production of a device like wind turbines or something. So one thing to keep in mind is whether automation is worth it. So automation is nice, is interesting, but sometimes you can get into sort of a pit of spending a lot of time automating something that you'll end up doing once. For that, I like this kind of funny but also very insightful comic by Randall Munroe, the creator of the XKCD comic, that tells you how much time it's reasonable to spend on automating a task, given how often you'll do that task and how long or how much time you'll shave off. So it's really surprisingly useful. So for example, if you're going to shave 5 minutes from each time you do that task, and you plan on doing that task weekly for the next 5 years, you can afford spending about 21 hours on automation for that task. So once you've decided you want to automate something, what's the process? So step one, I highly recommend that the first time you do the task manually. You stay aware of which steps you could potentially automate. You think about the automation process, but you don't automate anything yet. The second time you do you'll typically discover a bunch of things happening as when you do it the first time. Then the second time you do the same task, or the task on the new sample or something, you do it manually again, but you write down every step as you go. You want to build a flowchart of every single step, or a checklist. The third time you do it manually once more, but you follow the checklist or the flowchart. You want to update the flowchart to address every single issue, edge case, inconsistencies, and other variations you observe in your decision making and in your process. So you might have to repeat it 4, 5, 6, 10 times until you think you've encapsulated all the possible variations. And then, so you've done that a bunch of times, you have your flowchart. Then how do you think about automation? I think of sort of guiding principles of how to automate. So first, you want to encapsulate all of your decisions in the code. You don't want to have to interrupt your workflow and have a human in the middle giving its opinion about whether an imager is blue or red in a very simple case. So having a human in the middle, it's not repeatable and it's slow. Then you want to avoid being the human through which computers communicate, right? You don't want to be the one copying data from an email into an Excel spreadsheet or from a spreadsheet into a database. You want to, as much as possible, use APIs, application programming interfaces, to directly get computer readable information from all of your data sources. We'll have a great example of this in the case study in a minute. Then you want to use templates. So you want a base structure for the documents you need to create repeatedly every week, every month, or whose content changes frequently. So you have to update. Like a non-scientific example would be building a catalog where the photos change, the part numbers change, the prices change, etc. That template can be a Word document, it can be Excel, it can be a web page, but you need some kind of encode somewhere the underlying structure of your document. Then you want to use computers to make predictions, and that's usually the role of AI or machine learning. These models, they can consider much more factors than human can, and they can make decisions way faster and process way more data. But still, you want to be in charge of the judgment of those decisions. That's where humans can really bring in a lot of value. So now for the types of problems, I've highlighted sort of 3.5 or so. There are way more, but those are big buckets, types of automation problems that tools like Python are really good at. The first kind of problem is data transfers. It's taking data from place A, putting it in place B. Common examples of place A are getting data from the web, getting data from an email someone sent you, from spreadsheets, from Word documents, from text files, CSV files, PDFs. PDFs are the worst, but there's so much stuff in there. We're going to have another example of this in a minute. And then places where you send data to Excel is sometimes a source and a destination. Databases are often a destination as well. And then for analysis and reporting, the problems are that you're doing analysis on a data that's, let's say, in a spreadsheet again, and then you don't want to have to go in there, select some columns, copy some columns, rename columns, write your equation. That's something that the human has to do. Instead, you'll want to do the analysis outside of Excel and use Excel sort of as a dumb data repository. Then the other problems are your data is updated frequently or it changes very frequently. So again, in those cases, that's where you want to use templates. And for data that's live, that changes really often, that's where a dashboard is even better. We're going to have an example of this also. And then for problems where you have too much data, typically you can test an analysis. You can experiment on a few items, a few records of sorts, but you can't usually apply the same process to the whole data. You cannot manually do it because it's way too much. There are too many samples that have the same form. Each sample is too big for a single human to consume, or there are just way too many combinations of things to try. So let's see how to apply these principles to a few case studies. So the first one is a data transfer problem. Where I have something that's repeated through time, and also something where I didn't have an API. I had to consume data from the web into a PDF, into a numerical format. In this case, I just did a CSV file, and that also involved some data cleaning. So the data comes from a student. It's data from the California Independent Services Operator, which manages the California electricity market operations. So they produce these daily wind and solar curtailment reports. So they contain information about how much energy was not sent to the grid by wind farms and solar farms because of various reasons, like it would overload the system. So I recorded myself extracting data from one of those PDFs, which is on the left, and inserting it into an Excel spreadsheet. And I timed it. It takes about 2 minutes for me to clean everything up. And that's after I've practiced. I tried doing it a bunch of times so I knew the steps, and still it takes forever. So this 2 minutes, that does not include going onto the website, searching for the latest document and downloading it. So as October, there are about 820 of those reports, which means I need to copy data, not even plotting and thinking, and that adds up to more than 27 hours of work, right? That's basically a whole week of work just copying data, if you subtract like emails and meetings and that kind of stuff. Not an exciting week. All right, so what I did is I wrote a script to download the data and parse it into a format that's computer readable. Here I'm showing the code on the left. It's about 50 lines long. I generate the URLs for each of the files, and then I use a package called requests to download the PDF data. When I run it, it takes about an hour to download all the PDFs, which seems quite a bit of time, but I could do something else at the same time. I could do more valuable work. Or I could go to a meeting, or I could check emails, or go for lunch, or whatever. So an hour is a bit long. I'm in another version that worked slightly differently. It worked in parallel, and it could do the same thing in 4 minutes. So I went from 27 hours to 1 hour to 4 minutes. And then running it again takes about 2 seconds because the files have already been downloaded. It just has to download the data from the previous few days. So this script here is something that I would schedule to run daily on my computer, so I would always get the up-to-date data. So that's the first part, downloading the data. Then I wrote a second script about the same length, about 50 lines, 60 lines, that converts the PDF to text with a tool called PDF to text. It's a good name, as the name suggests. And then it uses pandas to clean up the data and append everything to a CSV file. So the little clip on the right shows that it takes about 20 seconds to parse and clean all the PDFs that I've downloaded. And even if I lose everything, even if I lose all the data, my computer crashes, I can re-download the PDFs and recreate the data in less than an hour, right? The download takes 4 minutes. This conversion here takes 20 seconds. And then I'm giving me 40 minutes to give myself 20 minutes to, like, I don't know, try to remember how I did that last month. So this is an example of a data transfer when there's no API, where I have to do quite a bit of work like this. Extracting data from PDFs is really not friendly. But really, if it's possible, you really want to consume data from an API. So here's a really similar data transfer problem, but this time I'm consuming data from the California ISO again. For some reason, they provide some of the data as an API and some of their data as PDFs. And there's a Python package called PyISO that can actually consume data from like dozens of American grid operators. So these 25 lines of code you're seeing here, they're enough to download the data, do some aggregation, hourly aggregation, and to make a plot. Right? So way, way, way easier if I can make the computers talk to each other without having me sort of have to manually do the data transformation in the middle. So there are two main takeaways here. The first one is try to go upstream to look for an API before even trying to parse data from a PDF, a Word document, or even a spreadsheet. The second takeaway, which is I think even more important, is if you are the person who is generating the data, if you're the person who created those PDFs, please, please, please do like Jeff Bezos said and expose your data through an API. And then if you absolutely need to generate those PDFs, consume data from that API to build reports, to build dashboards, or to build applications. At least you're allowing other people to build their own analysis from that data. So you don't want that data to be stuck in a document somewhere. So another use case here, in this case, a reporting case study. I'm using the output from the previous step. Like I said, for this webinar, I saved the result as a CSV file, but in a larger project, it would be behind an API. It would be stored somewhere in a central database, somewhere that my whole team can use it. So the setup for this case study is that I have been tasked to create, let's say, monthly reports that include the data for that particular month, as well as all the data up to that point in time. So this is probably a report that I have to create at the beginning of every month. But for the sake of demonstration, I'm creating all the reports here in one shot, but for the past 2.5 years. So to create these reports, I'm using three main libraries, Python libraries, Python docx for the templating of the Word document, Matplotlib to create the figures, and then pandas for the data manipulation. So I know the font here on the left is really tiny, but I'm showing it here to give you an idea of the scope. In total, it's about 170 lines. 2/3 of those lines are required to make the plots, label the axes, and make sure the labels are in the right places. Making good-looking plots tends to be a little verbose, but that's how it is. The remaining third splits the data into monthly chunks, and then for each of those months, creates the figures and then creates the reports. And then on the right-hand side, I have the Word document template that I created. I hard-coded some text, like the title, some context, and the general structure of a table there. And then if you go back to the code, the last 20 lines or so, they're actually the part that are dynamically replacing those placeholders. Oh yeah, so the placeholder for the table, and then if you see the lines underlined in red in the Word document, that looks like kind of gibberish English, those are placeholders that will be dynamically replaced. And like I was saying, the last 20 lines of this code, they dynamically replace the images, the text, they fill in the table, adding as many rows as necessary. The templating engine that I used, Python docx, is really nice. Even allows you to do formatting, but it's not something that I've used here. So here's now a complete report from last month, from September, with all the images that have been computed by the code in the previous slide. You can also see the table where all the values have been dynamically inserted. And then on the right-hand side, you'll see one file for each month of data that is collected. And you'll notice that if you look at the date modified column, they all have exactly the same timestamp. This tells you that it takes less than a minute to generate all of those reports once you've downloaded the data. So now I'm at 4 minutes to download and 1 minute to generate reports. So if you think about this case study from the beginning, 4 minutes to download the data, less than a minute to create the reports. We're really far away from the 27 hours required to just download the data. So this templating is nice. I've just saved myself probably hundreds of hours, but it's still stuck in an older way of thinking. Again, you've not changed your organization in this case. You're still sharing data through reports. I still need an item on my to-do list to remind me to do the reports every month. There's still someone somewhere who's waiting on these reports to make a decision. There's still a list of people who I need to remember to CC when I email this to people. So reports, yes, if your organization needs it, but it's even a better choice to build dashboards if it's possible, and to think beyond document-based reporting. So you should think in terms of live representation, of interactive representation of the data that's meaningful to you and to your audience. So something like a dashboard that has the information that our customer or manager or the entire organization cares about. So the benefits of that dashboard is that it's always up to date. You're never, ever waiting after someone. You just go there and you have the latest data. These dashboards exist in a single place, and they can summarize in one place multiple parts of the business. So for this case study, I'm using, again, the same data from the California ISO, and I created a dashboard using the really, really nice Dash library by Plotly. So on the left, I have the 60 lines of code required to create the dashboard on the right. So right now I'm selecting data from different months. At the top, I have the year for the data for all the past data, and you can see how there's interactivity. People can hover over the plot, see the exact values. They can zoom in to the particular moment in time they're interested in. So very little work, right? I could do this. I could add some extra comments. This is not pretty. I could make it like with the branding of my company without much effort. So those were 2 reporting use cases. And now I'd like to present 2 examples of having too much data. The first one is too much data, but not that much. So something that fits on disk. A good example of this is a task where you have to label data or to do some kind of transformation or analysis or feature extraction of multiple files, multiple images, multiple documents. Just something you don't want to do because it'll be super boring. Or it's going to be error prone. So for this example, I'm using a library called OpenCV for computer vision. And I made this sort of little, Art Nouveau or contemporary art looking example where I have a labeling tasks where I have images that are circles or triangles or rectangles, and I have to label their shape and identify the color. So I wrote this small script with OpenCV. It has about 70 lines, and there are 2 main functions in there: identify color, identify shape, and they both receive the image and they extract what they've decided. And then in this case, I'm just labeling the images directly. I could also have, I thought about building a small custom GUI that could just, I could fix labeling if they were wrong. I've not included that here, but I would add a sort of a measure of trust, of confidence that the algorithm has, so that it can present to me for review the labels that it the algorithm is not sure about and not show me all the stuff that it's confident about. So this kind of labeling task is something that new machine learning methods, that's something that deep learning is really, really good at, for example. And then the second, too much data, this is when you really have a lot of data, something that doesn't work on your computer, where out-of-the-box solutions don't work well, something that maybe like something like a dupe doesn't work well. You have a lot of time series, numerical data, signals, videos, that kind of stuff. So in this case studies, it's a custom application that stores the data in a central repository. It allows you to explore the data locally, so you can look at one sample, try some analysis, and then it allows you to run the same analysis on all your samples remotely on some cluster that your company or your team has access to. And it could work with arbitrary data. In this particular case, I'm using data from airplane test flights. So here, my application allows me to see multiple signals that I've measured on my airplane at a given moment in time. I can zoom in, everything is synchronized. I can even play the video, and the playback is synchronized with the signals from that airplane. So that data is stored on the server, but I can explore it locally. I can even drag it into my IPython prompt, and in this case it's stored as a pandas series, so it's a labeled time series of the signal. I can write some code to try to extract some features. So for example, I'm trying to find the parts of the signal where there's some high frequency parts, sort of the darker blue. Here I'm running that kernel, that signal processing locally. You see these red sections on the image. This is where I have that high frequency information. But then I can also, once I figured out the analysis that I want, I can also run this on multiple flights. So I'm gonna set some threshold value that I know works well. I'm gonna pick which signal I wanna apply my analysis to. I'm gonna apply that to all the flights. And I'm gonna submit that as a job. It's gonna run in a cluster somewhere. All these jobs are done in parallel, so if I have a really large cluster, I can do that really quickly. I can process terabytes of data if I need to. And the application collects live the result from those analyses. And what it returns in this case is regions of interest. So you'll see here that it's highlighting in red the portions of my signal that have this high frequency information. And I'm seeing that on one flight, but I can also look on another flight that has similar signals and look at where it found those regions of interest. All right, so I'm using it for test flight information here, but you can imagine doing this similar sort of parallel analysis for simulation results, for monitoring production runs, to do some analysis on the output of multiple chemical experiments or other things like that. So as a summary, here's how to think about automation. You want to automate vertically if you have too much data, or horizontally if your data has many steps, or if you're repeating those steps often. You want to do the tasks manually first to understand the problem space. You want to convert your decisions into code. You want to use APIs and provide APIs to consume data. You want to use templates for recurring documents and dashboards for live data. And then you want to use AI and machine learning to make predictions, but still be the judge of those predictions. And before I talk about the next steps that you can take regarding automation, I just want to let you know that when you leave this webinar, you'll be shown a short 4-question survey, and we'd really appreciate if you gave us a few minutes of your time and gave us some feedback about this webinar. So what are the next steps? What can you do now? If you're part of a group and would like some training on how to use Python for scientific automation, we provide on-site training for teams of scientists, engineers, analysts, and more. In those classes, we basically cover everything you need to replicate the case studies that I've built for this webinar. I like to say in those classes, I like to tell the students that I teach them how to put themselves out of work, not in a bad way, but in a good way where they can reduce the amount of repetitive work that they have to do, and that they can actually use all the harder knowledge they've acquired at school and in their in their career to be more valuable, right? They don't have to be the person copying columns in Excel. If you're an individual and you would like to attend one of our public courses, there's a calendar here showing the dates of our upcoming classes until the end of the year and at the beginning of next year as well. And you'll find all the details about those classes and how to reach us on our website, enthought.com, and you can go /training to see that directly. And if you're part of an organization that's looking at digital transformation, or if you're stuck in solving hard science problems and would like to know how we can help you accelerate your science and your transformation, please reach out to us so we can talk, so we can help you. You can reach out to us on our website or by emailing us directly at info@enthought.com. So with that, I thank you all for spending part of your day with us. I hope this was helpful, and I wish you all a good rest of your day. And we'll be we'll be sending you a recording of this webinar soon. So thanks again, and have a good day.